Hi.
Hello, Ramit. How are you?
Well, thank you. How are you?
I am also fine. Okay. So, in the previous session, you have learned about types of system.
Yeah.
And in today's session, I will move towards the approach of thermodynamics. Okay.
Okay.
What should be our approach of thermodynamics?
Okay.
Approach of thermodynamics means in thermodynamics, we basically study our system. Okay. We focus on our system. So what is the approach? What will be the approach to study our system?
Okay.
Okay. So basically, I will start from the approach of thermodynamics in today's session. Okay. So let's start the session.
Yep.
Okay. So in thermodynamics, we have basically two approach. There are two approach of thermodynamics. Okay. That means there are two approach to study any system. For any system, there are two approach. Okay. How we can approach, how we can study the system. Then there is then by two approach we can study about system.
Hmm.
And the two approach is, first is microscopic approach and second is macroscopic approach. Okay. I will i will tell about these two approach very deeply, so please understand this concept. There are two types, there are two approach of thermodynamics. First one is microscopic approach and second
Hmm.
one is macroscopic approach. Okay.
Okay.
Okay. So at first we will discuss about microscopic approach. Okay. So in the microscopic approach of thermodynamics, we basically concentrate on individual molecules. Why? Because here micro word is written in the microscopic, micro word is involved here, and this micro means molecular level. That means we study our system at molecular level. Okay. So this approach is called microscopic. Okay. Now understand, let us assume a system. Let this is your system, and in this system, let our working substance is air.
Hmm.
That means let us assume this is your room. And your room, air particles are present. Okay. So this is our system. Or you can say air is our system. You can say air is our system. And we have to study about this air.
Hmm.
I have told you what is system. System is a certain quantity of matter on which our attention is focused to
Yep.
study about that substance. Okay. So now in this system, air particles are present, and now we have to study this. We have to study about this air. A study of air means we have to find the pressure of this air. We have to find the temperature of air, volume of air. This is all about a study of air particles. Okay. Now, my dear, for a study of air particles, there are two approach. First one approach is called microscopic approach. Now let's understand this approach. This approach is at molecular level. That means this approach says we concentrate at first. We cannot concentrate on this whole system. At first, we concentrate on individual molecules. That means a single molecules. We concentrate on a single molecules. And after analyzing, that means after the study of these molecules, our concentration is shifted to another molecules. Understand Ramit, clearly?
Yeah, got that.
I will repeat this. Let us assume this is your first molecule and this is your second molecule, and let us assume this is your third molecules and this is your fourth molecules. Okay. In the microscopic approach, we first concentrate on single particle. That means first particle. Okay. Now I concentrate on this particle, one particle, and we study this single particle one. After studying this single particle, we have to concentrate on another particle. Now our concentration is shifted to this second particle, and also after studying this second particle, now our concentration is shifted to third particle, and we study these third particles. We analyze these third particles, and also after studying this third particle, our concentration is shifted to fourth particles, and here and in each stage we shifted our concentration to individual molecules. Now think, my dear, here in this approach, we concentrate on single particle, and after analyzing that particle, our concentration is shifted to another particle, and after analyzing that second particle, now our concentration is shifted to third particle. Okay, and this goes on continuously. So think, my dear, here in your system, air particles are present, and air particles are very large in number.
Yeah.
In your room, air particles are very large in number. So
Yeah.
when you use this approach, microscopic approach, then you have to give more time. You have to give more time to study your system. So this approach is very time consuming approach. Why? Because you concentrate on each individual particles one by one. After studying one particles, your concentration is shifted to another particle, and after analyzing that particle, your concentration is shifted to another particle. Since the number of particles are very large in number, so the time consumption in this approach will be very high. Okay, so we cannot use this approach in our thermodynamics. Why? Because the time consumption is very high here. Why time consumption is very high? Because air particles, the molecules are very large in number, and since this approach is a particle concentration approach, so we cannot prefer this approach in our thermodynamics. Okay?
Yeah.
Now, my dear, I will write some point here. In microscopic approach, here see the definition. In microscopic approach, the behavior of individual molecules is taken into consideration. That means we analyze single particle at a moment, and after analyzing that particle, our concentration is shifted to another particle. So this approach is also known as statistical thermodynamics. This thermodynamics is known as statistical thermodynamics. That thermodynamics in which individual particle is considered, that thermodynamics is called statistical thermodynamics, but we cannot prefer this approach. Okay. And now this one more point is added here. This approach is generally used at low densities, higher altitude. What does it mean? Then I will tell you about this concept. Please wait some minute. Okay.
Yeah, this one.
Now in microscopic approach, since the number of particles in a system is very large, so the time consumption in this approach is very large, is very high. Hence, we cannot prefer this approach. Hence, we cannot prefer this approach for our thermodynamics. Approach for our thermodynamics. Okay.
Yeah.
Now one question will be arise in your mind. Then where we can apply this approach? Okay. Now my dear, you see here, since the particles are very large, so time consumption will be high. Hence, we cannot prefer this approach.
Okay.
But my dear, in any system, think, my dear, in any system, if the number of particles are very less, suppose you have a system, and in that system, number of particles are very less. So we can apply this approach there. Why? Because number of molecules are very less. Okay. Now, suppose you have a system. My dear. You have a system, and in your system, there are very less molecules present. Let us suppose 5 molecules are present. Let us suppose very less number. Okay. Let us suppose there are 5 molecules present. Okay. Now, when we prefer this approach here number of molecules is very less. So after analyzing first molecule, our concentration is shifted to another molecule.
Yeah.
And also after analyzing this molecule, our concentration is shifted to another molecule. Okay. Hence, since the number of particles here is very less, so time consumption will be less. Hence, you can use this approach, but where the number of particles are very less. Because main factor is your time. If time consumption will be very large, then why we use this approach? But where time consumption will be very less, then we can apply this approach. Okay. So here number of molecules is very less, so we can use, time consumption. So time consumption is less. Hence, we can use microscopic approach here. Microscopic approach here. Now question is, where should I find less molecules? Okay. Now the question is, where should I find less molecules? Now, my dear, you have learned about density. Okay. Now, density is, my dear friend, density is your mass per unit volume.
Yeah.
Mass per unit volume. And what does mass means? My dear friend, mass is directly proportional to number of molecules. If number of molecules is high or large, if number of molecules is large in a number, then mass will be large, mass will be high. If number of molecules is less, then mass will be less. So mass will be directly proportional to number of molecules. And here, my dear, we have taken less molecules. Less molecules means here density will be less. Density will be less.
Yep.
So, my dear, in any system, if the density of the substance is very less, then you can use microscopic approach there. Why? Because density is very less. That means mass will be very less. That means mass will be very less. If density will be less, then mass will be less. And when mass will be less, that means number of molecules will be less.
Yep.
So in any system, if number of molecules is less, that means density will be less. So we can use microscopic approach there. Okay. If somebody asks you, dear, tell me where I can use microscopic approach of thermodynamics, then please tell where the density of the system is very less.
Yeah.
Okay. Density of the system is very less means number of molecules present there will be very less. And when number of molecules is very less, then we can use microscopic approach. Okay. And time consumption will be less.
Yeah.
Okay. Now, my dear, now I hope this is very clear to you. Now,
yeah.
Now, my dear, now again your question should be, sir, where density will be very less? Where the density is very less. So now, my dear, you have studied in fluid mechanics. This is, suppose this is your ground. And here, my dear friend, here atmospheric pressure is supposed to be acting. PATM, atmospheric pressure is acting.
Yeah.
When my dear, when we go upward, suppose 1 kilometer upward. Okay. Suppose you are here. Okay. And this distance is suppose 1 kilometer from the ground. Then, my dear, you have studied about this concept in fluid mechanics. When we go upward, then pressure reduces. Okay. Here at this point, pressure is reduced. I have denoted here the arrow sign downward. That means pressure decreases. If I will show you an arrow acting upward, that means that term is increases. Okay.
Yeah.
So at this point, pressure decreases. Okay. When you go upward, pressure will decrease. Now, my dear, in this space, air is present. In this space, air is present. Air is your gas. Air is your gas. Okay. In thermodynamics, you will study ideal gas equation. Ideal gas equation. You will learn about this ideal gas equation, and this equation is PV is equal to mRT. Okay. I will teach you about this ideal gas equation. PV is equal to mRT. Okay. Here we can write P is equal to M divided by V into RT. Okay. And this mass by volume. Here, please see, density is equal to what? Density is mass by volume. Mass divided by volume.
Yeah.
So this mass by volume is nothing but your density. So pressure is equal to, density is denoted by this term rho RT. Rho is your density. Okay. So from here, you can conclude that, sir, for gas, pressure is directly proportional to density. You can conclude for a gas that pressure is directly proportional to the density of gas. Now, my dear friend, now at this point, since pressure reduces, when pressure reduces, my dear, then what happened? Density also reduces.
Yeah.
That means at this point, density also reduces. This means at this point, 1 kilometer above the ground, at this point, air molecules present are very less in number. At that point, very less air molecules are present as compared to your ground level. Okay. Because density is less. And now, my dear, when density is less, then you have learnt here, when density is less, that means mass will be less and number of molecules will be less. So here, number of molecules of air present will be less. That means at a height from the ground, at a sufficient height from the ground, number of molecules will be very less. And when number of molecules will be very less, you can use microscopic approach there. Okay.
Yeah.
That means at a higher altitude, this is your altitude, at a higher height. Altitude means height. Altitude means height. At a higher height, you can use microscopic approach. Why? Because at a higher height, pressure reduces. That means density will also decrease. So number of molecules will be less there, and we can easily apply microscopic approach. Okay. So that means, my dear, at higher altitudes, altitudes means heights.
Yeah.
At higher altitudes, density will be less. So mass will be less, and mass less means number of molecules less. Number of molecules will be less. So we can use microscopic approach microscopic approach at higher altitudes. Okay. So, my dear, when a question is being asked to you, where does microscopic approach is used, then please tell where density is very less.
Yeah.
Then he may ask you where density is very less, where density will be very less. Then please tell at higher altitude.
Yeah.
At higher altitude, density will be less. Okay. So this was the concept in your microscopic approach, and I hope this is very clear to you now. Okay. Now, my dear, now I hope one sentence in the definition is now clear to you. This sentence, this approach is generally used at low densities, that means higher altitudes.
Yeah.
Okay. So this was your microscopic approach. Basically, we are here to discuss the approach for a study of a system. Okay. So there are two approach. One is microscopic. In microscopic, we study each molecules. We study each molecules. Okay. Now, my dear, now one more concept is here. Microscopic approach. This approach will be used in research. Is being used in research. Why? You know, in the research, they goes at molecular level. For them, time is not a factor. Even the time consumption is very high. Okay, this does not bother for them. So there will be no time factor for them. So they use microscopic approach. So for research, microscopic approach is used because they have enough time. But we do not have enough time. But researchers have enough time. Okay. Yeah. So they goes at molecular level to research. Okay. So one point is added here. One point will be added here, my dear. This approach is generally used in research purpose or in research work. Okay, my dear?
Yeah.
I hope whole concept is clear to you.
Yeah.
Okay. Now we are moving to the macroscopic approach. Okay. In the previous approach, micro approach, we do not prefer that approach, but in macroscopic approach, we prefer this approach. Okay. In our whole thermodynamics, we prefer this approach. Now understand what is the macroscopic approach. Now, my dear, suppose in your room, this is your room, and there are air molecules. There are number of air molecules present in your room. In this approach, we do not consider individual molecules. That means we do not concentrate our study on individual molecules. Okay. Then what? Here we concentrate on the whole system at a time. Here we concentrate not on individual molecules, but on the whole system at a time. That means number of molecules will be analyzed at a time.
Okay.
Therefore, the number of molecules will be analyzed at a time. In the previous approach, one molecules is analyzed at a time. But here, number of molecules will be analyzed at a time. So what happened? So here time consumption will be very less.
Yeah.
Because you are considering the whole molecules at a time. You are concentrating your study on whole molecules at a time. That means the time consumption here will be very less. Hence, we prefer this approach for our thermodynamics. Okay. Suppose in your room there are number of molecules, but here we consider on every molecules at a time. So in the given time we studied all these molecules present here. Okay, so the time consumption will be very less.
Yeah.
Now my dear, please see the definition here. The behavior of individual molecules is not taken into consideration. यहाँ पर in the microscopic approach, we do not consider individual molecules, but
Okay.
the average behavior of molecules is taken into consideration. Here we consider average molecules, that means whole system molecules. And this approach is also known as classical thermodynamics. Hence, we study classical thermodynamics. Okay, the thermodynamics you are studying is classical thermodynamics. Okay. Now, my dear, let's take an example here. Now, suppose this is your cylinder. Suppose this is your cylinder. Perhaps you have seen a cylinder in which any gas is present. And on the cylinder head, my dear friend, suppose perhaps you have seen here one pressure gauge is located. This is pressure gauge. Perhaps you have seen this type of cylinder.
Yeah.
Okay. Suppose this is your cylinder. And in the cylinder, any gas is present and a pressure gauge is located outside the cylinder on the cylinder head. Okay. This pressure gauge measures the pressure of what? Of which? This pressure gauge measures pressure of all these particles, of all these gas particles, not for a single particle. Suppose you are seeing the reading, obtained in pressure gauge. Suppose pressure gauge are showing 12 Pascal pressure. So this pressure is for whole system, not for a single molecules. This pressure gauge does not tell that this pressure is for a single molecule. This pressure is for whole system. That means for whole gas molecules. So for whole gas molecules, the pressure showing is 12 Pascal. That means pressure gauge is considering the average molecules. Okay. So what type of approach is this, my dear? This approach, yes, microscopic approach, because this is showing the result for whole the system, for whole the molecules. That means for average molecules. So this is behaving, this is showing the macroscopic approach, not microscopic approach.
Yeah.
If my dear, if this pressure gauge tells, if pressure gauge tells this pressure 12 Pascal is for first molecule and 14 Pascal for second molecule. If this happens there, then we can easily tell that this is showing the microscopic approach. But this
Yeah.
will not happen. But this will not happen here. Pressure gauge is simply giving the result which is for average molecules, that means for whole the molecules. Okay.
Yeah.
So this is showing your macroscopic approach. So this is your macroscopic approach. Okay. This is your macroscopic approach. Now, my dear, now please understand, in our atmosphere, okay, suppose this is our atmosphere in which we are living, in which we are living.
Yeah.
In this atmosphere, we have studied that at every point, atmospheric pressure is acting. At every point, atmospheric pressure is acting. And this pressure has same value everywhere. Suppose, my dear, suppose you are in London and I am in India, but in your room, the pressure that is acting on your head, same pressure is acting on my head here.
Yeah.
Okay. This means pressure, atmospheric pressure will be constant everywhere in the atmosphere. Okay. This means, my dear, this means in the atmosphere, molecules are very large in number. Air molecules are very large in number. But this atmospheric pressure that is acting on every body, every object, is this pressure is for every molecules, not for a single molecule. Okay, this atmospheric pressure is for whole molecules, not a single molecules. Okay.
Yeah.
I hope this concept is clear to you. In the macroscopic approach, we do not consider individual molecule. Here we consider average molecule. That means here we consider whole system. Okay. That means we study here the whole system at a point of time. Okay. So this thermodynamics is called classical thermodynamics. That means our thermodynamics is called classical thermodynamics. We prefer this approach everywhere. Okay. Now, my dear, we have seen the approach of thermodynamics. Okay. Now let's move. Now the next topic is thermodynamic equilibrium. Okay. Now, my dear, do not confuse the thermodynamic equilibrium with thermal equilibrium. Both are different things. My dear. Do not assume both are same. Okay. This is your thermodynamic equilibrium. Now, my dear, suppose a system is in thermodynamic equilibrium. Okay. That means that system